Hello everyone. In this session, we will be talking about operators in Python. So without wasting any more time, let's look at the agenda for this session. I will be starting with what exactly is an operator in Python and why are we using operators in Python. Moving further, we will discuss various types of operators that we have in Python. And next, we will see the precedence and associativity of operators in Python. Finally, we will see the non-associative operators. I will also be running a few examples in Jupyter Notebook for better understanding. I hope you guys are clear with the agenda. Now let's try to understand what exactly is an operator. An operator is used to perform operation between two values or variables. Now we can call the operators as constructs or special symbols to manipulate the values of operands. Now you must be wondering what is operand is. So the value that we use in operation is known as operand. These operands can be variables or any data type that we have in Python. Let's take an example here. We have two operands, operand 1 and operand 2. When I add an operator between them, we can get the result according to the type of operator that we are using here. Let's see an example. Here A is assigned the value 10, B is assigned the value 20. The expression A plus B uses the plus operator to add the values of A and B together. A and B are the operands. The plus operator performs the addition operation, adding the values of A and B. So the plus operator acts as the addition operator, where A and B are the operands on which the addition operation is performed. The operators in Python allow us to do the mathematical calculations, logical evaluations, data manipulations, and control flow in concise and expressive manner. Depending upon the type of operations, there are 7 types of operators in Python programming language. First of all, we have arithmetic operators, then we have assignment operators, comparison operators, logical operators, then we have membership operators, identity operators, and bitwise operators. So we will be discussing all these operators in detail. Now let's talk about the arithmetic operators. Arithmetic operators in Python are symbols used to perform basic mathematical operations on numeric values. This operator is a mathematical function that takes two input values, performs calculations, and produces a single result as an output. The most common arithmetic operators are addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. Here is a brief definition of each arithmetic operator. First, we have addition operator. The plus symbol is used to find the sum of two values. That is, it adds two operands. Next, we have subtraction. The symbol used is minus. This operator will subtract the right operand from the left operand. Next up, we have multiplication. The symbol used is asterisk. This operator will multiply two operands. Division. The symbol is forward slash. This operator divides the left operand by the right operand. Next, modulus. We use percentage symbol. The modulus operator returns the remainder after dividing the operands. And next, we have exponentiation operator. This is nothing but power. The symbol is double asterisk. This operator is used to raise the first operand to the power of the second. And finally, we have floor division. The symbol is double forward slash. The floor division operator divides the left operand by the right operand and returns the largest integer that is less than or equal to the result. In other words, it discards the decimal part of the division result and returns the integer quotient. Now let's understand the concept of arithmetic operators with examples. First of all, I will try to perform addition between two variables. The first variable is A. I am going to give this value as 10. And then I have one more variable B. I will give it a value 20. To perform addition between these two variables, I will just write plus over here. And when I execute this, I will get the sum of two values as output. Now to perform subtraction, I am going to use a subtraction operator. And you can see I am getting the difference between two numeric values. Similarly, I can perform multiplication. And we are getting the product of two numeric values. And then we perform division. On performing the division, we find the quotient when the first value is divided by the second value. And next up, we have modulus. This operator in Python is similar to division operator, but dissimilar to the division operator because it returns the remainder after dividing the first operand by the second operand. And similarly, we can perform exponentiation. For that, I will use double asterisk. This operator will find the power of the first value to the second value. And finally, I am going to do the floor division. This operation uses double forward slash. This operator is applied to two numerical values. First division will be performed. Then the result obtained from the division will be rounded down to the nearest integer. And this was all about the arithmetic operation, guys. Now let's understand the next operator that we have, which is assignment operator. Assignment operators are used to assign values to variables. They combine the operation of assigning a value to a variable with some other operation. And here is a list of assignment operators that we have in Python. First of all, we have assign, and next add and assign, then subtract and assign, multiply and assign, divide and assign, modulus and assign, exponent and assign, floor division and assign. Next up we have bitwise and assign, bitwise OR and assign, bitwise XOR and assign, bitwise right shift and assign, and finally bitwise left shift and assign. Now let's see each assignment operator one by one. First we have assignment operator. It is denoted by equal sign. It simply assigns the value on the right to the variable on the left. Secondly, we have addition assignment operator. It combines the addition operator with assignment. This operator is a convenient way of adding a value to a variable and updating the variable with the result. A increased by 5 is equivalent to A equals A plus 5. Next up, subtraction assignment operator. This operator is a shorthand way of subtracting a value from a variable and then updating the variable with the result. A minus 3 is equivalent to A equals A minus 3. And then we have multiplication assignment operator. This operator is a concise way of multiplying a variable by a value and updating the variable with the result. A multiplied by 3 is equivalent to A equals A asterisk 3. Division assignment operator. This operator is a shorthand way of dividing a variable by a value and updating the variable with the result. A divided by 2 is equivalent to A equals A divided by 2. And then we have modulus assignment operator. This operator calculates the remainder when a variable is divided by a specific value and updates the variable with that remainder. A modulo 2 is equivalent to A equals A modulo 2. And then we have exponentiation assignment operator. It calculates the result of a rising variable to the power of a specific value and updates the variable with that result. A to the power of 3 is equivalent to A equals A to the power of 3. Next up, the floor division assignment operator. It performs floor division on a variable with specific value. This operator takes the current value of the variable and divides it by the specific value. It discards the fractional part and assigns the result, that is the quotient, back to the variable. A floor divided by 3 is equivalent to A is assigned the result of A floor divided by 3. Moving further, we have bitwise AND assignment operator. This operator is used to update a variable by performing bitwise AND operation with a specific value. Then what is bitwise AND operation? The bitwise AND operation is a binary operation that is applied to each pair of corresponding bits of two operands. And here is how the bitwise AND operation works. If both bits are 1, the result is 1. Otherwise, the result is 0. Let's see an example. Now we're going to perform the bitwise AND operation for this expression. That is A bitwise AND equals 7. Or we can say A AND equals 7. Here we are going to perform a bitwise AND operation between the current value of a variable A and the value 7. And then we will assign the result back to A. For instance, let's say A initially holds the value 12. Its binary representation is 1100. 7 in binary is 0111. Now perform the bitwise AND operation between the binary representation of A and 7 at each corresponding bit position. The AND operation evaluates each pair of bits. That is, if both bits are 1, the result is 1, otherwise it is 0. After performing the bitwise AND operation, A will hold the value of 4. Its binary representation is 0100. And this is how the bitwise AND assignment operator works. A AND equals 7 is equivalent to A is assigned the result of A bitwise AND 7. Similarly, we have bitwise OR assignment operator. This operator takes the current value of a variable and performs a bitwise OR operation with a specified value. Then it assigns the resulting value back to the variable. Now let's see how bitwise OR assignment operator works. Let's break down the expression. The expression we have is A bitwise OR equals 4. Let's say A initially holds the value 6. Its binary representation is 0110. The value 4 in binary is 0100. Now perform the bitwise OR operation between the binary representation of A and 4 at each corresponding bit position. The result of the OR operation is 1 if at least one of the corresponding bit is 1. After performing the bitwise OR operation between A and 4, we have the result 6. Its binary representation is 0110. A bitwise OR equals 4 is equivalent to A is assigned the result of a bitwise OR 4. And next we have bitwise XOR assignment operator. This operator works by performing a bitwise XOR operation between the current value of a variable and a specified value After that, it assigns the result back to the variable. And here is how the bitwise XOR operation is done. Here we're going to perform a bitwise XOR operation between the binary representation of A and 5 at each corresponding bit position. The XOR operation results in 1 if the bits are different and 0 if the bits are same. Let's say A is represented in binary as 1010. The decimal value of A is 10. The value of 5 in binary is 0101. After performing the XOR operation, the binary result is 1111. So the variable A is updated to the decimal value 15. So A bitwise XOR equals 5 is equivalent to A is assigned the result of the bitwise XOR 5. Next we have right shift assignment operator. This operator takes the current value of the variable and shifts its binary representation to the right by the specified number of positions, and then it assigns the resulting value back to the variable. Now let's see how it works. Now the decimal value of A, which is represented in binary as 110010. Here we perform the right shift operation on the binary representation of A by the specified number of positions. In this case 2. The right shift operation effectively divides A by 2 raised to the power of the specified number of positions. This is equivalent to dividing the decimal value of A by 2 to the power of 2, which is 4. Now the variable A will be updated to the new value, which is a result of dividing a original value by 4. After performing the right shift operation, the result is 001100. Its decimal equivalent is 12. A right shifted by 2 is equivalent to A is assigned the result of right shift by 2. And finally we have left shift assignment operator. This operator takes the current value of a variable, performs left shift by specified number of positions, and assigns the result back to the variable. Now let's see how the left shift assignment operator works. Let's say we have a variable A which is represented in binary as 110010. Its decimal equivalent is 50. Here we perform the left shift operation on the binary representation of A by specified number of positions. In this case we have 3. Now the variable A will be updated to a new value, which is the result of shifting its binary representation to the left by 3 positions. That is effectively multiplying A by 8. This is equivalent to multiplying the variable A by 2 to the power of 3, which is 8. The left shift operation appends zeros to the right of the binary representation. On doing the left shift operation, we get the binary number 010000. Its decimal value is 16. Now let's take it up to Jupyter Notebook to understand these assignment operators. Now I have a variable A which is assigned a value 5. And this is the basic assignment operator, which is denoted by equal sign, which simply assigns the value on the right to the variable on the left. And next we have addition assignment operator. On writing this, what will be the output, guys? Now I'm going to print A. I get the value as 10. Here it take the current value of A and add 5 to it. Then store the result back to A. A plus equals 5 is essentially same as writing A equals A plus 5. Now let's try to understand the other assignment operators as well. Okay, now let's dive into bitwise and assignment operator. And initially we have a variable A which is set to 10. The value of A will be 2. Test out the different assignment operators on your own. And this was all about assignment operators. Now let's talk about the comparison operator. In Python, comparison operators are used to compare two values, and the result of the comparison is Boolean value. That is true or false. Here are the common comparison operators in Python. Equal to, not equal to, greater than or equal to, and less than or equal to. The equal to operator checks if two values are equal. Not equal to operator checks if the two values are not equal. The greater than operator checks if the value on the left is greater than the value on the right. Less than operator checks if the value on the left is less than the value on the right. Greater than or equal to operator checks if the value on the left is greater than or equal to the value on the right. And finally, the less than or equal to operator checks if the value on the left is less than or equal to the value on the right. These operators can be used in various situations such as conditional statements, loops, and other places where you need to compare values. They also work with strings, lists, and other types, not just numbers. Now let's see some examples on comparison operators. We will be exploring the numeric comparison. Here we have two variables A and B and assign the value 5 and 10 respectively. First we will use the greater than operator to check if A is greater than B. And you can see the result is false because 5 is not greater than 10. Now let's do string comparison. Here we are using two strings containing apple and banana. In this case, I am using the equality operator to check if the string 1 is equal to string 2. On executing this, the result is false because apple is not equal to banana. The logical operators are used to perform the logical operations on Boolean values. It is often used to combine or modify the conditional statements. There are three main logical operators in Python, which are AND, OR, NOT. The AND operator returns true if the both operands are true, otherwise false. The OR operator returns true if at least one of the operand is true and false otherwise. The NOT operator returns true if the operand is false and false if the operand is true. It essentially negates the truth value. Here is a simple example using Jupyter. In the first part, we are initializing two variables x and y with the values 10 and 5 respectively. First, I am using the logical AND operator to check if both x and y are greater than 0. I am getting the output as true because both x and y are greater than 0. And next I am using the logical OR operator. It checks if at least one of the numbers x or y is greater than 0. And we get the output as true. This is because either x is greater than 0 or y is greater than 0. Since we have x as 10 and y as 5, therefore the entire expression evaluates to true. And similarly I am checking for logical NOT operator. This code will check if x is not equal to 0. And you can see the result is true since x is not equal to 0 because it is 10. So the entire expression evaluates to true. Now we are done with the logical operators as well. Now let's try to understand what are identity operators. In Python, identity operators are used to compare the memory locations of two objects. These operators do not compare the values of the object, but instead check if the two variables reference the same object in memory. There are two identity operators in Python, which are is and is not. What is does is it returns true if both the variables point to the same object. Otherwise, it returns false. Is not will return true if both variables do not point to the same object. Otherwise, it returns false. Now let's try to do this in Jupyter Notebook. In this snippet, we have three variables. The variable A refers to a list with values 1, 2 and 3. The variable B refers to a different list with same value as A. Even though it has the same value as A, it is a distinct object in memory. The variable C refers to the same list object as A, and this is because of the assignment C equals A. After this code, A and C both reference the list 1, 2 and 3, whereas B references a different list of values 1, 2 and 3. Now let's use is operator. I am checking A is B. It returns false because A and B refer to different list object. Now I am checking A is C. It returns true because A and C refers to the same list object. Now let's see an example using is not operator. First I define two variables. There is number 1 and number 2 with values 5 and 10 respectively. Now I'm going to check if the numbers are not the same object. When you run the cell, the output will be true, meaning that the two numbers are not the same object in memory. And this was all about the identity operators. Now let's talk about the next one, which we have as membership operators. Python membership operators are used to test whether a value is a member of a sequence or not. The two main membership operators are in, not in. In returns true if a value exists in a sequence and false otherwise, whereas not in returns true if a value does not exist in a sequence and false otherwise. These operators are commonly used with strings, lists, tuples and other iterable types. Now let's see an example for in. Now I'm creating a list called fruits containing the elements apple, banana and orange. Now I'm checking if banana is in the list. When you run this code cell, you will output true because banana is present in the fruit list. You can also use the not in operator with the same list to check if a particular element is not present. When you run this code, it will output true because grape is not present in the fruit list. The not in operator is used to negate the result of the in operator. That is, if the element is not in the list, it returns true, otherwise it returns false. Moving further, we have bitwise operator. The bitwise operators compare the binary values. These operators perform operations on the binary representation of integers. Each bit in the binary representation of an integer corresponds to a power of 2. The bitwise operators manipulate these bits according to specific rules. Here are the main bitwise operators in Python: bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift, and right shift. Bitwise AND operator compares each bit of the first operand to the corresponding bit of the second operand. If both bits are 1, the resulting bit is 1, otherwise it is 0. The bitwise OR operator compares each bit of the first operand to the corresponding bit of the second operand. If at least one of the bit is 1, the resulting bit is 1. Similarly, bitwise XOR compares each bit of the first operand to the corresponding bit of the second operand. If the bits are different, the resulting bit is 1, otherwise it is 0. The bitwise NOT operator flips each bit. That is, if bit is 1, it becomes 0, and if it is 0, it becomes 1. The left shift operator shifts the bit of the first operand to the left by the specified number of positions, and it fills the vacated positions with 0. The right shift operator shifts the bit of the first operand to the right by the specified number of positions. The vacated positions are filled based on the sign bit of the signed integers. That is, if the number is positive, its leftmost bit is 0. The right shift moves all the bits to the right, and the vacated positions on the left are filled with 0. If the number is negative, its leftmost bit is 1. The right shift moves all the bit to the right, but the vacated positions on the left are filled with 1s to maintain the negative sign. Let's see some simple examples on bitwise operator in Jupyter Notebook. Let's perform the bitwise AND between 10 and 12. The result is 8, and we know that the bitwise AND will set each bit to 1 if both the bits are 1. Now let's perform bitwise NOT. This expression involves two bitwise operations, that is bitwise AND and bitwise NOT. First, it will calculate the bitwise AND between 10 and 12. So the result is 8. And next, it will apply the bitwise NOT to the result of 10 and 12. So the result is minus 9 in decimal. And you can see the bitwise NOT operator inverts all the bits. Now let's see an example for left shift. Here we have a number 10. The left shift operator performs the left shift on the binary representation of a number. So it moves all the bits to the left by the specified number of positions. In this case, it will shift by 2 positions. The binary equivalent of 10 is 0, 0, 0, 0, 1, 0, 1, 0. On shifting these bits to 2 positions to the left, we get 0, 0, 1, 0, 1, 0, 0, 0, which is 40 in decimal. Shifting left by 2 position is equivalent to multiplying the original number by 2 raised to the power of 2, which is 4. So in this case of 10, you are effectively multiplying 10 by 4, resulting in 40. And so far we have seen what are all the operators that we have in Python. Now let's understand the concept of operators precedence in Python. In Python, operator precedence determines the order in which the operators are evaluated in an expression. An expression is a collection of numbers, variables, operations, and built-in or user-defined function calls. Operators with higher precedence are evaluated before the lower precedence operators. If operators have the same precedence, the associativity of the operators comes into play, which determines the order of evaluation. And note that the parentheses have the highest precedence in Python. So the expression within the parentheses are evaluated first, which override the default order of precedence. If there are nested parentheses, the innermost expressions are evaluated first. And here is the list of operator precedence including parentheses at the highest level. Parentheses have the highest precedence, so any expression within the parentheses is evaluated first. Exponentiation is the next level of precedence. It involves raising a number to the power of another. Unary operators comes next, and they affect the sign of a single operand. And next up we have multiplication, division, floor division, and modulus. These operators perform the basic arithmetic operations. Addition and subtraction have lower precedence than multiplication, division, floor division, and modulus. And then we have bitwise shift operators. These operators perform bitwise shifts to left or right. The bitwise AND operator represented by AND holds the 7th precedence, and it is evaluated before bitwise XOR, bitwise OR, and comparisons. Next, the bitwise XOR operator has the 8th precedence. In 9th precedence, we have bitwise OR operator. Moving on, the comparisons takes the 10th precedence. After that, we have the logical NOT with 11th precedence, followed by logical AND at 12th precedence. Next up, we have the logical OR with 13th precedence. Finally, the assignment operators in Python have the lowest precedence. Let's see some examples on order of precedence. Look at the first expression. We have 2 plus 3 times 4. In this case, the expression doesn't have any parenthesis, so the multiplication takes precedence over addition. Therefore, multiplication is performed first and then the addition. That is 3 into 4 is evaluated first because multiplication has the higher precedence, which results in 12, and then the result of the multiplication is then added to 2. So the final result will be 14. Let's see one more expression with parenthesis. So in this case, we need to evaluate the expression inside the parenthesis, which is 2 plus 3 equals 5, and then multiply the result by 4. So the result of the expression is 20. Let's see one more complex expression with parenthesis. In this expression, we have two parentheses. The parentheses around 2 plus 3 and 4 minus 1 indicates that the addition and subtraction operation within each set of parentheses should be performed before the multiplication and division operations. So evaluate the expression inside the parenthesis. 2 plus 3 inside the first parenthesis is evaluated to 5. 4 minus 1 inside the second parenthesis evaluates to 3. Now substitute the evaluated values back into the expression. Once this is done, perform the multiplication and division operations. Now we have the value as 15 by 2. On evaluating this, the final result is 7.5. We can see in the table that more than one operator exists in the same group. And these operators have the same precedence. So when two operators have the same precedence, associativity helps to determine the order of operations. Now let's understand the concept of associativity of Python operators. Associativity refers to the order in which the operators of the same precedence are evaluated in an expression. In Python, most operators are left associative, meaning that they are evaluated from left to right. whereas exponentiation is right associative. And here is a simplified examples for both left associative and right associative operators in a Jupyter notebook. Now let's look at an example with an addition operator. We have the expression 2 plus 3 plus 4. The addition operator is left associative. So first we will be evaluating 2 plus 3, and then the result of this grouped expression is added with 4, and the final resulting value will be 9. And here the addition operator is grouped from left to right. Now let's explore the right associative behavior with the exponentiation operator. And here is an expression 2 to the power of 3 to the power of 2. In this expression, the exponentiation operator is right associative. So it is evaluated from right to left. First 3 is raised to the power of 2 is evaluated, which is 9. Now replace 9 in the original expression. So we have 2 power 9, which results in 512. Chaining comparison operators and assignment operators do not have associativity in Python. Now let's start with chaining comparison operators. Consider this expression. There is 10 less than 20 less than 30. The expression is evaluated from left to right. In Python, the expression is evaluated as two separate comparisons connected by the logical AND operator. It first translates to 10 less than 20 and 20 less than 30. This means that both conditions must be true for the entire expression to be considered true. So it's not checking if 10 is less than 20 and then if that result is less than 30. Instead, it checks if 10 is less than 20 and simultaneously if 20 is less than 30. Similarly, when we encounter a chained assignment expression like this, all the variables a, b, c and d end up with the value 42. The Python evaluates it in a sequential manner from left to right. First, it assigns the value to a and then assigns the same value to b, followed by c and finally d. So it is not a simultaneous assignment of the same value to all variables. Instead, it is a step-by-step assignment starting from the leftmost variable.